Hi, I'm Lauren Paulson, and today I'm going to go over Lab 3, which involves analyzing the magnetic field produced by a bar magnet. The physics principles involved in this lab are, of course, magnetic field, but specifically the correlation between magnetic field and the distance away from a magnet you are. It also analyzes the Biot-Servat law, which is the equation shown. So our procedure for this lab is to line up our phone with north. To do this, we lie our phone on the table and rotate it until the x component of the magnetic field is equal to 0. Then we need to lie down a meter stick perpendicular to the direction our phone is placed. The next thing we need to do is locate the magnetometer on the phone. To do this, we need to slide the phone in both the x and y direction and see when these minimize or maximize and mark the axes of this with tape. Finally, we will either move the phone or move the magnet so that they are different distances apart from each other and record the magnetic fields at this distance. We will do it on the same line, and then we will also do it at a 45-degree angle. These were my results from this experiment and a graph created from ln bx over ln r. I then put these results into my code, using the Biot-Servat law to calculate the magnetic field, and then looking at the observation axis and the perpendiculars, and then finally graphing all of those for how they would look at their specific position, and then also analyzing what this means the B field would be at 45 degrees. This image is the result of my glow script code once it is run. As we can see, the purple arrow is the final 45-degree field. And then we also get the different axes and the different magnetic fields at the perpendicular, and the final B, which is again represented by the purple arrow. Now, what would have happened if we hadn't have oriented our experiment to compensate for magnetic north, and instead laid out the meter stick at some angle that wasn't perpendicular to Earth's magnetic field? How would our experiment be different? Now, our magnetometer reading would be skewed in the direction of magnetic north, since this would be now affecting what is going on. And our values of K or mu and N would be way less accurate because magnetic north would be now affecting these values, instead of these values just being impacted by the bar magnet. Now, what would happen if we stuck two identical magnets together and ran the experiment again? What would change? So the direction of the magnetic field wouldn't change, it would be in the exact same direction. But the magnitudes of the magnetic field would almost double. They would be slightly less than double due to the magnet having length and therefore being further away from the phone. But if we ignored the length, it would be double. I hope you guys enjoyed my presentation on Lab 3, and thank you for watching.